This video is to explain to you about the variable IF in the Collins unit. Variable IF. You'll see people in the conferences throw that around. None of them know what they're talking about. It took me a while to catch on. Now, in order for me to explain to you the variable IF, I have to explain to you the first half of the radio. Now, the first half of the radio, when you turn the band selector switch, moves several coils. It moves 3 coils into position. Now, in this case, we'll be discussing band 4, 80 meters, which is between, that band is between 3 megacycles, or megahertz, and 4.5 megahertz. There's 3 coils that work on a rack system. So these 3 coils go into position, and they don't move after that. You're on band 4, 80 meters, they're in position, they don't move. That's it. You come in from the antenna, you go to the first coil, it tunes the band. And then it passes it to the amplifier, it amplifies it, and then these output coils basically shunt out any unwanted frequencies above or below. It's just a band pass. Then it goes to the mixer. No big deal there. Here's the difference. The first oscillator in the radio is fixed. It's 6 megahertz. So the 80 meter band is going to get converted as a block. The whole 80 meter band gets converted together. So 3 megacycles, or megahertz, becomes 2.7 megahertz. 3.5 goes down to 2.5. 4 becomes 2. 4.5 becomes 1.5. Now, these 4 selected frequencies that we're doing just for the example, these are now IF frequencies. They're intermediate frequencies. They're the ones that the variable IF is going to use. It's that simple. This is fixed. Once you get into your band, that's it. That whole band, any frequency you're picking up, is now been converted. So now we go on to the next thing. Here's the IF variable unit. It's basically a radio. That's all it is. Depending on what part of the band you're on, these coils change. And what they do is they track along with the oscillator, with the VFO, the PTO. So this is basically a radio with a mixer, and it produces 500 kilocycle IF. That's all it is. This is a radio, part of a radio, that all it does is take those frequencies that have been knocked down in frequency, and it tunes them in, it mixes them and makes the IF, which then goes on to, you detect it and you get your audio. So when you're turning your oscillator, your main tuning, that your PTO is low in frequency. It goes between 3 megahertz and 2 megahertz. And the same with the 2 converter coils. They basically, it's a tune front end. That's all this is. It's just a radio right here. So they call it a variable IF, but really it's a radio front end. As the second would be a dual conversion. It's the second conversion section. So there's no real amazing trickery. The only thing is, as this PTO is moving, there's a rack that holds these coils, and they move up and down to the oscillator. And when you're receiving 3 megacycles, let's do 3.5. When you're receiving 3.5 megacycles, you're actually receiving it at 2.5. It's been turned into an IF frequency, and then it mixes with this oscillator, and it gets turned into 500 kilohertz, or kilocycles. Kilohertz is the new word. So there's no real big deal. See, they had me bamboozled, because I'm like noticing, when I first realized that when you turn the band switch, that these coils are all seem to be moving. Well, they just, that's just the way it is. They don't want, if you were to go from band to band to band, and only the coil you wanted to move moved, then it would be real tricky mechanically to get the one on the next frequency to move. So they move them sort of all together, and that's just to make it mechanically more efficient. It doesn't look efficient, but it is mechanical wise. But I just want to tell you, the Collins radio is very simple once you get the concept that you're taking the incoming frequency band and you're knocking it down in frequency. That's so their patented PTO can stay very stable because it works at a low frequency. See, all the other competition, they were using frequencies, oscillators that would go up in frequency and would be above the incoming frequency. And that's the problem. As you go up in frequency, you start getting a bad drift problem. Well, Collins says, well, we'll block convert every frequency, no matter what band you go to. First, we'll have the pre-selector unit in there, the bandpass filter, and then the frequency will hit a crystal, and it'll block convert the whole thing down in frequency, and then we'll use our patented oscillator on it. And we won't have drift. We won't have the problem that the competition has. And that's why the Collins, if you talk to old timers, yeah, Collins is the one to have. It was. Hammerlin was good. I've had Hammerlins. I have Icoms. I got Nationals. I don't have any Helicrafters. I consider them total garbage. There are a few models that are okay, but overall they really don't give you what you paid for. They eliminate a choke in the power supply. The IF cans are junk. They were equal to a table radio. Other radios, the IF cans, when you open them up, you could tell there's really good. They're really well made inside and crafted, and all the IF cans in the Helicrafters are all the same bandwidth. They put 3 all the same, where other ones have a wide to narrow. Even a cheap transistor radio, the 3 IF cans are different. So there's certain reasons why I just don't like Helicrafter stuff. But there's no real problem understanding how the Collins works. It's just that you have to understand they're converting the band down in frequency. And if you come over here and you think you're going to use this oscillator into a frequency counter, you're wrong. This works backwards. I explained that to you. In my radio, my Collins simulator radio, I added an extra NE602 to invert it again, so my oscillator would work in the correct direction so I could use a frequency counter. But Collins didn't worry about which direction the oscillator worked in, because the dial is calibrated. So when you turn to 5 megahertz, you're getting 5 megahertz. The radio is not even working on 5 megahertz. It's working on a different frequency, but it doesn't matter. You want 5, we'll convert it down in frequency. It'll work great with our oscillator. So when you tune in 5 megacycles, probably on 8. Say it would be probably 3 megacycles you're actually really receiving in the radio itself. Go look it up, go figure it out. But in other words, they did something really special, and I give them a lot of credit. And this was the last thing for me to understand. And I still have to figure out how they switched these coils for the bands. Don't forget, you turn these coil banks, and they move the coils, the pistons in the coils into position. But there's also a wafer switch that changes the connections. There's a lot to a Collins radio, and that's why it took me so long to get it all working, because the wafer switch was in such bad shape as far as oxidation. But it is a great radio. But compared to a modern radio, the sound is not that great. And it's nice to have a digital radio. But I just wanted to show you. This is the famous variable IF. The frequencies that are coming in here are from the band, the block converter band. In other words, it converted the entire 80 meters down in frequency, comes in here, and it gets tuned by these coils, and it hits the mixer with an oscillator, produces 560 kilohertz. I'm still using KCs. Well, that's what actually was on the schematic. But in other words, this is just a second radio inside the unit. And then there's also filters you can add to the radio. But we won't go there because they're over in here. But I just wanted you to understand that variable frequency, the variable IF, is a buzzword that on the conferences people will bring that up just to baffle you. You know, they can't dazzle you with brilliance. They baffle you with bullshit. I think that's it. All right, that's it. Hope I didn't misspeak too much.